Good morning, everyone. This is graph-powered mining and analysis of SE Linux security policies. My co-authors are Professors Amir Iman and Hugh Chipman. And my name is Pete Jadzik, and I, at the time, was an undergraduate summer student, and I'll be taking you through this presentation. So the focus of this presentation is going to be the analysis of SE Linux security policies. SE Linux is a distribution of Linux which implements mandatory access control strategies. So those are beyond the discretionary access control used by ordinary Linux distributions. And so mandatory access control takes control of files beyond the regular kind of ownership system where file access is controlled primarily by who the owner of a file is, and it instead implements several additional mechanisms for access control. For the purpose of this analysis, we're going to look mostly at type enforcement. So maybe I can explain what type enforcement is. Type enforcement typically involves labeling that basically gives every system resource a label, and it divides these things into subjects, which are processes, and objects, which are files and sockets. And so you can see on this page the name attribute. This is the label that SE Linux gives any type of subject or object. And then some type of action or access is requested by the subject on the object. We use the terms access and action fairly synonymously throughout this. And so basically everything boils down to what subject is trying to access what object in what way. And SE Linux works on the principle of least privilege, which means every grant of any type of access must have corresponding allow rules in the security policy to permit access. And this is where we get into policies, and that's kind of the crux of what we're trying to show through our analysis is these security policies, which ultimately allow or do not allow access. So the problem with SE Linux is that, yes, it allows a very high level of detailed customization for these security policies, but they also become very, very complicated and complex. And so it's not uncommon to have potentially hundreds of thousands of such policies, and then keeping track of them and managing them can be very difficult. It can often result in behavior which maybe administrators have a difficult time tracing. Users won't be able to access a file, and it's very tough to pin down exactly what policy is preventing that. So there have been previous attempts to fix this problem. One previous solution, for example, is to extract all these policies, so these hundreds of thousands of policies, into a CSV file. There's a tool, Apple, that comes with the capability of doing this. It already exists, and so once the data is extracted, it's mathematically applied to represent an adjacency matrix. And this is definitely a step in the right direction, but the math can be really difficult maybe for some people to understand, and the analysis can still be quite slow and mathematically intensive. And so we propose instead to use graphing analysis for these policies. And so to actually graph the policies from this CSV file, where each subject and object is entered as a node, each access becomes a relationship between the nodes, so the link between them. And so why would you use graphing? The benefit is that analysis of these can be highly flexible, and it allows for either very simple queries if you want to kind of keep things simple, just to answer some questions, or potentially very complicated and very specific queries. And so you get lots of flexibility in the analysis tools. Furthermore, graphs visually represent things, making understanding between connections and nodes much easier for most folks than trying to kind of figure out a mathematical solution to this. And so admins can use this to create very specific and very broad analysis of these policies. So this is an example of a node that we've uploaded, and the benefit is we use Neo4j of Graphing Database, but you can use other ones. But the benefit of Neo4j is that you can upload these CSVs automatically, which when you're dealing with hundreds of thousands is very, very key. And so you just import the CSV file, you create all these nodes, all these subjects. These are the sample attributes that come with the node, and they're basically what you're seeing is representations of various columns of the CSV. And then you can structure your queries specifically to maybe look at some of these attributes or the names or some of the relationships between them. So Neo4j uses the Cypher language, and kind of the beauty of these queries is that they're quite simple to understand. So this is an example of one. And even if you don't understand Cypher at all, you can still already probably gain a pretty quick understanding of what it is that's being matched here. The other benefit of graph databases is that unlike SQL queries or relational databases, graph databases do not have to perform a Cartesian product to retrieve all the relevant data. And so these queries can scale quite well exponentially once you start adding multiple nodes and multiple tables. And so using these queries, you can do various types of analysis. And this is kind of really the crux of it. You can do, node to node relationships to find out what kind of access is allowed just by querying those nodes. You can do, group to group or flow paths to see, well, is one of my nodes maybe indirectly affecting another node that I didn't realize just by evaluating the relationships. And then you can also do reachability things. So this is where we get into things like security analysis of maybe whether a process has access to some other socket that it shouldn't have access, just by seeing whether or not it can reach that socket through various accesses or actions. And so, this is very much a step in the right direction, but I think in the future, we're hoping to see maybe some machine learning used to develop these graphic models in kind of more efficient ways. Maybe like some sort of user interface software for the everyday folks to be able to conduct these queries, or even some sort of software that's built right into SE Linux that comes as a ready-made application for that environment and infrastructure. So that's a very quick summary of the project. I want to say thank you very much for your time. I really appreciate it. And if you have any questions, please don't hesitate to reach out to any one of us. Our contact emails are listed on the slide. And thank you very much for your time.